Okay, if you're watching the video, we're getting kind of a late start on class because of the senior awards assembly, so I'm going to bust through this a little bit quickly. We're not going to do all of these, you guys, just so you know. I just kind of want to touch base with a couple of them so you kind of get the general feel for what's happening. I'm on 1-3. There's 2 of them. I'm on 1-3. The first question says, as you drive on the highway, you accelerate to 100 feet per second to pass a truck. After you've passed, you slow down to a moderate 60 feet per second. The diagram shows the graph of your velocity, think speed, as a function of the number of seconds, t, since you started slowing. So this is kind of a graph of your speed, your velocity, kind of what happened over time. Number 1 says, what does your velocity seem to be between t equals 30 and t equals 50? What's that speed look like? Yeah, we're going about 60 feet per second. It says, how far do you travel in the time interval, 30 to 50? Well, we know that distance equals rate times time. We're looking for distance. We know that our rate is 60, and how much time passes from 30 to 50? That's a question. How much time passes from 30 to 50? 20 seconds. So our distance would be 1,200 feet per second. Everybody with me? Number 2. Explain why the answer to problem 1 can be represented as the area of a rectangular region in the graph, and shade the region. We're not going to write the answer, we're just going to talk about it. They say that if you find the area of this space right here, that is the answer. Well, let's think about this. Each box is how long? Isn't that 5 seconds? Right, 5? And as far as each unit, isn't it 10? What's 10 times 5? 50. So if you count all these boxes in here, or if you use your magical multiplication skills, and you multiply it by 50, you'll get 1,200. So if you count up all the boxes in here, which there would be 4 times 6, right? 24? 24 times 50 gets you 1,200. Oh, yes, I'm sorry. Thank you. 1,200 feet. Thank you. So the area underneath the graph does have something to do with finding some of these answers. And when you find antiderivatives, and now we're actually switching over to kind of integrals, which kind of involve the same kind of thing. When you're finding an integral, you're actually finding an area under a curve. There's a lot of applications for it. There's lots of ways to talk about it. But because I've only got 1 day to teach this concept, all you need to know going into Zamer's class next year is it's basically you're looking for area under curve. You'll find out more about it next year, but that's kind of what you need to take home today. So area under the curve. Go ahead and we're going to skip the rest of this page and move on to 1-4. Like I said, we're going to go fast. Rocket problem. Elevator. Dart's daughter. Elevator. That's crazy. I just now said that out loud and realized what it sounds like. Elevator. Dart's daughter is driving in her rocket ship. At time t 0 minutes, she fires her rocket engine. The ship speeds up for a while and then it slows down as, I don't even know how to say that, Alderans, is that right? Elderons, gravity takes its effect. The graph of her velocity v at t miles per minute is shown below. So here's kind of her deal there, and here's our 8 seconds. On number 1, it says, what concept would be used to estimate her distance between 0 and 8 seconds? We just talked about how it's area under a curve, right? The problem is that over here, it was pretty easy because it made pretty much a rectangle. You guys know how to find area of a rectangle. You probably don't know how to find the area of something bizarre like that and get an exact answer. You could estimate, you could count the boxes and then multiply it by how many square units each box is, and that would get you there, but that would be an estimation. There's even a closer estimation if we say, okay, I'm going to divide this into 4 sections, so go ahead and divide yours into 4 sections. And I'm going to turn each of them into a trapezoid. Now, it's not exact. I mean, these lines are kind of snuggled up next to the actual graph, but it would kind of get you there. You could add the area of 4 trapezoids, and you could get an even closer answer, I would say. Wouldn't you agree? Like, so that this right here, this little guy is 1 trapezoid. Does everybody see that? It's on its side. So we could do that. would the area be more or less accurate if I made more trapezoids? Like, what if I divided each of these sections into, if I split them all in half? Yeah, it'd even be even more accurate, right? So the more trapezoids you have, the more accurate that thing is going to get. And Ms. Zamer will talk to you next year about, this is where limits kind of get involved, because it would be ideal if you could get the width of each trapezoid to be basically 0, right? And you could fit in an infinite number of trapezoids in there. Does that make sense? If it doesn't, it's okay. You don't have to know it to finish today's assignment. But that's kind of where you're headed next year, just so you know. The whole point of today is to know that there is a rule for calculating a whole bunch of trapezoids together at one time without doing them individually and then adding them together. And it looks like this. So take your paper and flip it over. And at first, this is going to look really crazy. I just want you to stay with me. It is not hard. But when you first write it, you're going to go, what? That's insane. It's not. This is the trapezoidal rule. I'm sorry, I'm going fast. All right, we're going to write down b minus a over 2 times n. I'll explain those letters in a second. Just roll with me. Times f at a plus f at a plus 1. Nope, 2 times. Sorry, 2 times f at a plus 1 plus 2 times f at a plus 2 dot 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 plus 2 times f at b minus 1 plus f at b. Do what? What's what? The dot just means that, I mean, you fill in the middle and you keep following the same pattern until you're done with the pattern. It'll make sense in a second, Carson, I promise.
Yeah, is that last one a 6 or is that a B?
It's a B, I'm sorry. That's a B. Good question. The problem that you get is going to look something like this. It's going to be like, it's going to have an integral. There'll be a number on the bottom. We're going to call it A, and a number on the top. We're going to call it B. And it's going to have some kind of function in the middle, and then it's going to say dx. This is indicating a change in x. We're going to, derivative, basically. It's a derivative. This is going to be kind of your function. You can see A and B. That for this trapezoid problem, we're going from 0 to 8. So the integral would have been 0 to 8. That's what those numbers would have been. And then it'll either give you n or you'll have to figure it out. And there'll be some sort of number here. And n is the number of trapezoids basically under the curve. So I'm going to put number of trapezoids. And they're all equal in width, just so you know. So here's our first example. We've got an integral. We're going from 0 to 4. The function is sine of x. We've got a dx. And they're going to tell us, they're going to put 4 trapezoids under that curve between 0 and 4, and you have to calculate the area. That's what that question says. So according to the formula, we start out by saying b minus a over 2 times n. So b is 4 minus a, which is 0, over 2 times n, which is 4. Are there any questions so far? Okay, times. According to the formula, we just take f at the number that's on the bottom of the integral. So the function at 0. What happens if you put a 0 into the function? What is sine of 0? 0. Plus, the next piece says 2 times the function at the next value. So we're going to say 2 times, okay, the next value we don't know, or do we? Oh, you know what? Shoot, I really screwed this up. I got 2 of my examples confused. Put pi up here. Otherwise, you're going to make yourself crazy. Put pi, sorry, it'll make this a lot easier than using regular numbers. If we're dividing 0 to pi into 4 equal parts, what's the next part? Where is that going to be? Like if I have a line, here's 0, here's pi, and I divide it into 4 parts, how big is each line? 1/4 of a pi, right? So we have pi over 4, half a pi, and Yeah, thank you, 3 pi over 4. So I'm going to have 0 from putting in 0, and then we say 2 times the next value. So I'm going to put in pi over 4. Sine of pi over 4, what's that? Unit circle. Radical 2 over 2. Yes. Plus 2 times, what's my next value? What's my next value? Okay, hang on, let me back up. Hang on. Okay, hold on. This is your notes, so you might want to write this down instead. Put 0. Actually, don't. You can write out the long way. This is sine of 0 because we divided it into 4 parts. So then this little guy right here is sine of pi over 4. This little guy right here is going to be sine of what? Pi over 2. And then we're going to have plus 2 times sine of what? Good, Ocean. And then plus, we're going to have sine of pi, right? Yes.
Okay, so the equation, it says 2 function of a plus 1. So what would it be?
It just means like the next value.
Okay.
Yeah. Yeah. I didn't know how else to put that, so we just said the next value. Good question. So we have 2 times, what is sine of pi over 2? 1. Better know that unit circle.
Plus 1 doesn't mean you have 1.
It's the next interval. It's the next value, like whatever the next little interval is. We'll do another example. It'll make more sense, I think. Sine of, what's pi of 3 pi over 4? Sine of 3 pi over 4? Negative 8, a million, 2.5. Do you really know? Radical 2 over 2, is it positive or negative? Positive, because it's in the second quadrant. Now the last value, and you'll notice from the formula, the guys in the middle are all multiplied by 2. The guys on the ends are not. So we just have to figure out the sine of pi, which, by the way, is 0. Type all this in your calculator, and don't forget to multiply by pi over 8. It's just the formula, sweetie.
The last one you don't
First and last don't get multiplied by 2. First and last, neither one. And we'll get a decimal answer, and that's fine. What'd you guys get? Anybody?
Why is the sine of 3 pi over 4 positive?
Because it's in the second quadrant, and all students take calculus. Second quadrant is positive for sine.
I thought 3 pi over 4 was between the third and fourth quadrant on the bottom.
3 pi over 4 is it's in the second quadrant. Because pi is 180 and it's before pi.
Okay, yeah.
It's okay. That's all right. What'd you guys get? Sounds good. 1.896. Any questions with where that came from? Type this in. Multiply by pi over 8. She's working.
Okay, I got that.
Okay, now she's good. All right, next example. This morning. All right, we're going to go from integral 0 to 5. We're going to do 3x cubed dx, and they're going to tell us that they want 5 trapezoids. I'm going to keep talking out loud for those of you that need it. Try to work it without me. Your first step is b minus a, so top minus bottom, so 5 minus 0, over 2 times n, and they tell us n is 5, times the function at the first value, which is going to be 0. If I plug in a 0 there, I get a 0, plus 2 times the function at the next value. Well, I'm only going from 0 to 5, and they want 5 trapezoids, so the next values are just 1, 2, 3, 4, 5. So if I put a 1 in there, 1 cubed times 3 is 3. Plus 2 times, I put in a 0, I put in a 1, I need to put in a 2. 2 cubed is 8, 8 times 3 is 24. Plus 2 times 0, 1, 2, now I need to put in a 3. 3 cubed is 27. 27 times 3, 81. Plus 0, 1, 2, 3, I need to do 4. So 2 times, if I put a 4 in there, 4 cubed times 3, somebody tell me, what is that? 192. Thank you. Plus, the last guy does not get multiplied by 2. I just need to take a 5 and shove it in there, and what is that? Thank you. Oh yeah, 125 times 3. And then we work all that out. Somebody type that in for me and tell me what you get. Don't forget, sorry, it's my phone. Don't forget to multiply by a half. Anybody?
975.
487.5. Don't forget. Yeah, you can't forget to multiply by that half. This little guy over here on the left. So 487.5. Are there any questions of how this is supposed to go? One more example, and it's going to look a little bit different. They might give you information that looks like this. They might actually give you like a T-chart where you have time and like maybe velocity at time and you're trying to find distance. And let's say when no seconds have passed, velocity is 0. Let's say 1 second goes by and you're at 15 miles an hour. 2 seconds go by, you're at 40 miles an hour. 3 seconds go by, you're at 65 miles an hour. And you see a cop, so at 4 seconds you back off down to 50. Using the trapezoidal rule, you're supposed to calculate what that distance is. And that's all you're given. So your integral, what are the top and bottom numbers? 0 to 4. So on the top I have b minus a. So I have 4 minus 0 over 2 times, uh-oh, they didn't tell me n. Do we have an n?
Yeah.
What is it?
4.
Is it 4 or 5?
5. It's 0. Yeah. Saying 5.
Think about how many trapezoids you would fit from 0 to 4. Together this makes one trapezoid. Second trapezoid, third trapezoid, fourth trapezoid. Do you guys see that? So n is actually 4.
Yes.
All right, so then we have times the function at 0. I don't have a function. What do I do? Do we have to have it? They give you the output right there. They tell you what it is when you plug in these numbers. They've made it easier on you. What? So we have at 0 it's 0, plus 2 times at 1 it's 15, plus 2 times at 2 it's 40, plus 2 times at 3 it's 65, plus 2 times at, oh wait, we're done, yep, no 2, at 4 it's 50. So the middle ones get multiplied by 2, the first and last do not. And we work it out, and so tell me what you get. $265. Whoops. 145? 145. And as far as labels and all that goes, you guys will talk a little bit more about that next year and kind of how to come up with all that stuff. But can you get the numbers? Is everybody okay? Okay. Yes. That, yeah, what this is this means like b minus 1 would be the second to the last value before you get to b. You know what I'm saying? Like this was, For example, for this one, b was 5. You put in a 5, you put in a 4. b minus 1 is 5 minus 1 is 4. You put a 4 in. That's why that came from. Does that make sense, Tiffany? Okay, great question. Okay, your assignment is on the board. It's page 316, 1 through 10, 49, 52, 53. That's it. It's on the board.
Oh, okay.
It's on the board. Page 316, 1 through 10, 49, 52, 53.